Hello everyone, today I will present to you about our paper, namely Text-Enhanced Data-Free Approach for Federated Class-Incremental Learning. First of all, let's start with some background information of federated learning. In the definition, federated learning trains locally on each device instead of centralizing data. And it aims to train the server model, using knowledge from all clients' data. But please note that, in this setting, clients and server can't access each other's training data. However, in real-world applications, local user data changes constantly. This raised the need of federated class-incremental learning, which tackles updating server models with new data from novel classes while retaining old knowledge. There are several methods proposed to address this problem, however target can be considered as SOTA methods. In this pipeline, in the first task, they only use the cross-entropy loss to train each client. After that, for each communication round, the server is calculated by aggregating all client parameters. We call this process as model training phase. When the new task T coming, they will use the generator to data-free synthesize data from server at task T1, we call it as data-free generation phase. After that, both new and synthetic data are used to train client models in model training phase. However, we found that current methods lack the synergy between model training phase and data-free generation phase. In that, since it only using the CE loss, the latent space of existing method is disorganized and make the generator face challenges in synthesize the high-quality images. To address this issue, we propose to use the label text embedding as the anchor and constraint the feature embedding around them to enrich surrounding area with more meaningful information. After that, by using LTE as anchor, we applying NAYER to synthesize more meaningful samples. Thanks to the well-organized latent space and the information of anchor LTE, we can generate the far better synthetic data for addressing the forgetting problem. However, it also raised the problem of how to effectively anchor the feature embedding. In that, the naive solution is use the MSE loss for feature constraints. However, it can make the latent space is too tight and lacking natural difference. We propose the bounding loss to address this problem, which encourages sample embeddings to stay within a defined radius rather than strictly adhering to the anchor LTE. Here is the TSNE chart of our lander and target. It is clear that our lander generates data in latent space that closely resembles real data compared to target. Here is experiment results in CVPR 100. The result demonstrates that lander outperforms prior methods by 2 digits in both accuracy and forgetting score in all settings. Our method shows the improvement in the experiment in large-scale dataset. Here is some synthetic data of our methods in ImageNet dataset. Here is some reference in this presentation. Finally, thank you for your watching.